Let's jump right in. Welcome back to The Explainer. Today, we're exploring the ultimate digital drafting board, the platform that quite literally turns theoretical infrastructure into physical reality. We're talking about AutoCAD, the foundational software behind the spaces we live, work, and travel in every single day.
Okay, picture this. You're tasked with designing a massive, multi-lane bridge spanning a deep river. How much room for error do you have? Zero. Absolutely zero. You can't exactly hit undo once thousands of tons of concrete have been poured, right? A single miscalculation is disastrous, which means the tools our civil engineers rely on have to be practically flawless.
Real quick, here's our roadmap for today's explainer. We'll be hitting the zero margin for error, inside the AutoCAD toolkit, building the real world, overcoming design challenges, and finally, the future of infrastructure. Let's get to it. Section 1, the zero margin for error.
So, in the high-stakes world of civil engineering, guessing is literally not an option. A single tiny miscalculation, that means astronomical delays or terrifyingly severe public safety hazards. Back in the day, a misplaced decimal point on a piece of paper could literally result in a highway ramp missing its connection entirely. Insane, right? But today, this software acts as the ultimate mathematically precise safety net, calculating down to exact millimeter tolerances to completely eliminate the human error of hand-drawn geometry.
The jump from old methods to modern digital workflows is just night and day. Imagine going from giant, clumsy paper blueprints and manual protractors, where human error is basically a given, to interconnected, cloud-based workflows. It's an intelligent platform now. It runs automated checks that catch disastrous mistakes way before a single shovel even touches the dirt.
Section 2. Inside the AutoCAD toolkit.
So how do they actually guarantee those exact measurements? Well, it all comes down to some absolutely crucial foundational tools. Take layer management, for example. It's kind of like having X-ray vision for a building. You can completely hide the plumbing layout so you can focus entirely on the electrical wiring without your eyes crossing from visual clutter. Then you've got precision tools like object snaps and puller tracking that mathematically force your lines to connect perfectly. Throw in automated macros to handle all the boring, repetitive stuff and incredibly detailed annotations, and suddenly engineers are actually freed up to creatively solve problems instead of just spending tedious hours drawing basic lines.
And speaking of saving time, dynamic blocks are a massive productivity boost. These are reusable parts that adapt in size and shape without you having to redraw a single thing. Imagine you're designing a huge hospital with hundreds of doors, and they're all just slightly different. Instead of drafting every single one from scratch, no way. An engineer just pulls a dynamic block from their custom library and it instantly snaps to fit the specific project parameters. It enforces consistency and honestly saves thousands of collective hours.
But it gets even cooler when we talk about BIM, or Building Information Modeling. This connects the drafting board to a massive, real-time ecosystem of project data. Because of cloud collaboration, those old, frustrating silos of project management are just gone. You could literally have a structural engineer in Tokyo, an architect in London, and a project manager in New York, all tweaking the exact same 3D model simultaneously. They can instantly spot and fix physical space clashes right there in the file.
Section 3. Building the Real World.
The real-world impact here is just massive. Seriously, shifting a mouse a few pixels on a screen literally dictates where tons of concrete and steel are safely placed in the physical world. In roads and highways, this software handles crucial stuff like alignment and drainage grading. For bridges, it's doing intense structural analysis. In buildings, it's drafting architectural floor plans and running complex structural simulations. And for broader infrastructure, it's mapping out the hidden veins of our cities. That water you turn on at the tap, the gas for your stove, all of that is planned, mapped, and born inside the software environment.
Section 4. Overcoming design challenges.
Now look, mastering a tool this ridiculously powerful is definitely not without its hurdles. Think of these best practices as a survival guide so your massive project doesn't collapse under its own digital weight. First off, you really have to invest in training. The learning curve is famously steep. It's definitely not an app you're going to master over a lazy long weekend. Second, utilizing strict file management and layer organization is totally non-negotiable for handling unwieldy global projects. And third, users have got to stay informed and quickly adapt to regular software updates, otherwise you're just leaving major efficiency gains on the table that your competitors are absolutely using.
Section 5. The Future of Infrastructure. So where is all this heading? Well, as tech evolves, AutoCAD isn't just going to design our world, it's going to help make it dramatically smarter and greener.
By 2026, we're expecting to see some seriously enhanced 3D immersive capabilities. Think blending with virtual reality so you can easily visualize a space before construction even begins. Over the next 5 years, watch for much deeper AI integration to automate the highly complex, mundane tasks. And looking 10 years out, the big focus is going to shift heavily towards specialized tools for modeling eco-friendly, highly sustainable structures.
To sum it all up, as technology evolves, so too will AutoCAD, continuing to pave the way for innovative and efficient engineering solutions. It really has completely transformed from a simple digital drawing board into a totally active partner, one that tests our boldest ideas and mathematically guarantees they can survive the harsh realities of the physical world.
Which brings us to a really fascinating thought to leave you with today. As AI continues to automate more and more complex drafting tasks, what totally new, seemingly impossible structures are engineers going to be freed up to dream about? How will tomorrow's evolving digital blueprints drastically reshape the physical skylines of our future? Keep that question in the back of your mind the next time you look up at a massive skyscraper or drive across a suspension bridge. Thank you so much for joining me on this explainer, and I'll catch you on the next one.